Hello everybody, in this lesson I will discuss the 3 exam questions below on the geometry of 2D figures. Now can you remember your famous toolbox with all your maths reasons in, all the geometry reasons? Now you have an additional toolbox, and this one contains the 2 rules for similar triangles, and that is 2 triangles will be similar when 3 angles are equal or when their sides are in proportion, and triangles will be congruent. There's 4 reasons: either side, 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 or side included angle, side, angle, angle, side, and when you're dealing with a right angle triangle, RHS, right angle, hypotenuse, side. Question 1. Prove that triangle MNO is congruent to triangle NOP. Now when you go to your 2 triangles, you can see that side MO is equal to side NP. That's given with a little green stripe on top of the side. Then there's also angle N1 and O1, and this little symbol indicates that they are right angles. And then very specifically, MO is the side that's opposite the right angle. So MO and NP, they are indeed the hypotenuse of each triangle. And then you can also see that side NO, this side is common to both triangles. So we can prove the 2 triangles congruent by starting with in triangle MNO and triangle NOP. Angle N1 is equal to angle O1, and the reason it's given that both are 90 degrees. MO side is equal to side NP, that was given, and they are both hypotenuse. And then we can say that NO is equal to NO, that one is the common side. Therefore, triangle MNO is congruent to triangle NOP, and the reason RHS. And remember, that stands for right angle hypotenuse side. Question 2. Prove triangle AD is similar to triangle ABC. And the second part of this question wants us to determine the length of EC, which is this one. Now let's start with the first part of this question, where we need to prove that triangle ADE, the little triangle, is similar to triangle ABC, the big triangle. Now, remember, when we want to prove 2 triangles similar, we need to find 3 angles that's equal. So we can start by looking at the little triangle ADE and see that angle A is equal to angle A. It's the common angle for both triangles. Furthermore, it was given that DE is parallel to BC. And in our little toolbox, we have a rule that says when two lines are parallel, we find corresponding angles. Therefore, we can say that D1 is equal to B, and the reason corresponding angles equal. And then remember, I said you don't even have to think about this one. You can say that angle E1 is equal to angle C, the remaining angle. E1 is equal to angle C, and your reason can either be corresponding angles equal or third angle of a triangle. Therefore, triangle ADE is similar to triangle ABC, and your reason, angle, angle, angle. Now, the second part of this question wants us to find the length of EC. In order to do that, we need to write down the ratios. So we can say, since triangle ADE is similar to triangle ABC, we can write down the ratio. AD over AB is equal to the ratio DE over BC is equal to the ratio AE over AC. And remember, when you write down the statement there, you have to give me the reason because the two triangles are similar. Now let's quickly fill in all the lengths of all the known sides. Therefore, AD we don't know, AB was given that it's 20. DE is 13 and BC is 52. AE is 12 and AC is unknown. Now what are we looking for? We are looking for EC. Now do you agree that EC is actually part of this whole length AC? So my suggestion is, if only we can work out the length of AC, then we can subtract this 12 and we find the length of EC. So in this case, it's bye for now for this one, and we will work with the 13 over 52 is equal to 12 over AC. And then we can cross multiply. 13 AC is equal to 12 times 52, which is 624. Divide away the 13, therefore AC is 48. But that's not what they wanted. They wanted EC. So AC is the big side there. To get EC, we will rather say EC is equal to AC minus AE. AC we calculated was 48 minus AE was given that it's 12. Therefore, EC's length is 36. Before we continue, have you subscribed yet? Or you can like this video, and better yet, please tell your friends about my channel. Let's continue. Question 3. Quadrilateral ABCD is similar to quadrilateral PQRS. Determine the length of AB and QR. Now, since it's given that the two quadrilaterals are similar, we can now write down the corresponding ratios, and the ratios are equal. So we can start by saying the ratio AB over PQ is equal to the ratio BC over QR is equal to the ratio CD over RS is equal to the ratio AD over PS. Now let's see. For the first one, let's choose AB over PQ and AD over PS. Let's see what's happening, because we want the length of AB. Therefore, AB over and PQ's length is 10 equals AD's length is 3 over and PS's length is 7,5. And then we can only multiply away the 10 and we end with AB is 3 over 7,5 times 10 and AB's length is 4. Then, in order to work out the length of QR, let's take BC over QR, that's equal to CD over RS, those two. BC is 2,4 over QR, that's what we're looking for, is equal to CD is 6 over and RS is 15. Then we can cross multiply and we can say that 6QR is equal to 2,4 times 15, which is 36, and we can divide away the 6, therefore QR's length is 6. In the next video, I will discuss more exam questions on the geometry of 2D figures. Click on the video in the left-hand corner to take you straight to the next video.